Good afternoon, everybody. This is most likely the most complicated keynote because it's one after lunch. So Florian has the difficult task to keep you awake for the next hour. I didn't see many of you getting a coffee over there, but there's still some. So thank you very much. We are going again to start soon. Next keynote is indeed Florian Rochereau. Well, I will not disclose who he is because he will talk about himself, but he runs his own business in Shanghai, so it's technically a local on all levels, and is one of those guys that makes things happen for real. So we have seen quite a few projects from Arturo, from digital to physical, and then to AI. Now I think we'll have a big bump into physical reality and also much bigger scale to some extent in respect to what we have seen this morning. So it's a pleasure for me to invite Florian to join here to the desk, and let me start your presentation. Sorry.
Okay, this is working?
Yes.
Okay, thank you, Davide. Thank you, Giancarlo. Thank you, Mia, for the invitation to speak in front of you today. It's a real pleasure. The title I chose for this presentation, An Engineer Imagines, is actually not from me. This comes from a book that is written by Peter Rice. Peter Rice was, because he died already, was a legendary engineer. He has been working on the most iconic building in the world, such as the Sydney Opera House, for example, the Louvre Pyramid, or the inverted pyramid as well with IMP, or for example, the Centre Pompidou in Paris with Renzo Piano. And this, why I start my presentation like this, because this is quite special for me. When I first came to China in 2011, 2012, so about 12 years ago, I came here for an internship to do my final master degree internship, 6 months I have to do to get my engineer diploma. And I did it in RFR, Shanghai. At that time, Peter Rice founded his own small studio in Paris in 1982, where they were specialized in special structures and complex facades. And they had opened a branch in Shanghai, in Asia. And I did my internship in RFR, Shanghai. And at that time, I had the opportunity to work as a graduate engineer, to work some very interesting projects, a wide variety of projects, from all the scales that you can imagine, smaller projects to bigger projects. But especially, I had the chance to work with great people. And I learned literally everything that I know today. And then a few years later, so I came for an internship, 6 months in internship, and I stayed in RFR for 8 years. So a few years later, end of 2019, so right before COVID, I decided to try and start my own small studio. And my studio is called Bespoke. So we are engineers with passion for design. But by the way, those are the first page and the last page of my studio brochure. I've been asked not to be too silly, not to sell too much my studio today. So I just put the first and the last page. And yeah, on the last page, it's written this. Of course, computers are doing all the jobs. We are just telling them what to do. So I'm sure actually that, you get the ironic sense of this sentence, right? Because it's not just about giving some orders or requests to a computer and gets what you want and what we need as an engineer. It's more about developing like processes and solutions to get our orders and requests as clear enough so that the computers and the digital tools can give us what we want and what we need. Because for us, as engineers, the last things we want is to lose control over our process. We don't want to be, as this title is saying, like lost in all these parameter spaces. Okay. I'm sure that many of you guys have already experienced this kind of pictures of our grasshopper definition. And this is exactly what we are trying to avoid in our day-to-day practice when we work on real projects. And I'm not saying that this does not happen to us anymore. Okay, we are still, it's true, sometimes not taking the best decisions on when we think about solutions for projects, and that can lead to, I mean, not that in extreme way, but lead to something that we are not fully in control with. And it's also because we are too often lazy to organize our thoughts first before jumping into digital tools. Because yeah, it's take a lot of energy to clearly think and organize our own thought before to like linking the wires together and put many components on Grasshopper like this. You know, I receive this kind of Grasshopper quite often, whether it is from other colleagues or other people working on projects with us. And when I receive this kind of Grasshoppers, basically we have two choices. Or we spend hours or days to dig into it and try to understand someone else's logic, basically. Try to modify some inputs and see that actually you don't get the output that you want because the data management or the way it's sorted has not been really thought in a clear way, or at least as the way that I need for myself. And the other solution is actually to spend days and hours to understand the real problems behind the real questions that we have to solve. So first of all, understand the real questions, make it clear in your mind, and then after jump to Grasshopper and apply what you have already clearly in your mind defined as logics, as solutions, into digital tools. So I let you guess which option I prefer. So today I would like to share with you 2 or 3 points or 2 or 3 concepts that we try to apply as much as possible in our projects when we develop solutions for projects, and that help us to stay in control of our process. So the first one is about abstraction. A model, by definition, is an abstraction of the reality. Building a model means actually reducing the infinite complexity of the real world to a level that can be described with manageable efforts. And today, with all the extremely powerful computers that we have, all the almost unlimited storage space that we have access to, it is very easy to add more and more information into our models, for example, because we think that more information is better. But actually, a perfect model is not the model that contains as much information as possible, but it's rather like something that contains as less as necessary to be able to describe the properties of an object in a clear way. So abstracting geometry is a point where we really like to start and begin when we start to think and develop solutions for a project. This shape, for example, that you see on the screen, it's a shape that we developed for a shell structure in south of China, Shenzhen, in Qianhai area. This shape comes from a combining process that we have developed specifically for this project. So the overall shape is self-determined and is constrained by all the boundary conditions and the force that we apply during the confining process at that time. And for this kind of structure, with very curvy geometry, with large cantilever, it's extremely important to get the shape right at the beginning. Because if you don't get it right, then it can very easily like end up with oversized member or like very not efficient, like inefficient structures or additional columns that we would not need with a good shape. And then this is the final pictures of the project. So I intentionally jump from very abstract shape to the final picture of the project to show you that two of them, like from very abstract geometry to final building, are completely linked together. And the final building that you see here, all the elements, all the nodes, all the details, are coming from this very abstract shape that you saw at the beginning. So this is why, for us, it's extremely important to spend time from the beginning to get it right. And spend spend really a lot of time to be sure that the first point of when we say abstracting geometry, we get it right from the beginning. Otherwise, all the error, all the mistake that we are having from the beginning, they are just increasing and they add together, and then we end up having solutions that looks strange. So there are other pictures of the final building. Yeah, so the cantilever from there is a touchdown here, and the column is about 40 meters. It's quite a large cantilever. Another project about abstracting geometry. This one, we did it with maybe an architect that you know, Mad Mayenson. Okay, you like the design or not? I mean, this is not the question. This is not important today. But here, this is a project in Xiamen. The client came to us to help them to get this, the architect scheme, to get it built within all the constraints that you can imagine. So constraints from fabrication processes, constraints from materials, constraints from schedule, and also, maybe the most important, constraints from budgets. So after getting all those reference surfaces, so very curvy surfaces from Mayenson, MED, I should say, not Mayenson himself, but we started to think about it. And considering all those constraints that we got from the real clients and all the construction and everything, we decided, in this case, to rationalize all the very curvy, double curve geometry using straight lines. And so this became all those patches. We have 6 patches on the project like this. This is one of them. Became what we call in geometry a ruled surface. And then again, I jumped from very early stage during the design process on pictures to the real construction to show you that the things we define in the very early stage, when we abstract all those concepts, they are extremely linked to the final building. And those are things that will drive the whole construction. In this case, so you see those lines, completely straight lines. And because it's straight lines, here we choose to use aluminum extrusion, because aluminum extrusion, you can get them extremely straight. The horizontal members, they're in steel, and the vertical one, they are in aluminum. So all those patches, they are suspended from the top of the building, from the 2 slabs on the tops, and the horizontal here that you see with those struts, they're only here for lateral stability. And those are final pictures of the building. So we fit all the architecture surfaces. We find the best orientation, the best space between those lines. Okay, we optimize the parallelism of those lines in order to fit as much as possible the reference surfaces from MAD. And finally, after optimization, the other surfaces compared with their surfaces was having, if I remember well, like 400 millimeters deviations. It was quite okay for them. Some other pictures. Okay, so this was about geometry and shapes. But architecture design, it's actually not only about defining shapes. After the shape is defined, we have to come with, a lot of details, a lot of components needs to be joined together, and they are linked to main structure. So everything needs to come together to get the final object that you want, or the final building. And you can see, this kind of very curvy structure, this is what we usually do, and the kind of structure that we are working on. And as soon as the underlying grid is not regular anymore, as soon as you are working on a very curvy types of structure, then in this case, all the detailing becomes very important, because in theory, every details needs to adjust to every single position, and all the angles of the details needs to be adjusted according to its own location on the structures. And then all the details are basically Unix in theory. So today, when I say abstraction in the context of like the detailing, this is actually to find a systematic solutions that meets all the criteria and where we can find for all the individual parts and individual components of a building. So you can see this kind of structure that we have designed. This is in a project in Shanghai, by the way. And finding a generic solution that meets all the criteria for the connection parts, for example, for those kind of details, this is not that straightforward, because from the beginning of the when we start to work on the project and develop solutions, we have to think of those kind of detailing from the beginning. The choice that we are making at the beginning when we define the reference surfaces will have effects to all those kind of detailing choice and will have implication in the next decision that we are taking. So in this structure, this is like defined by 3 layers of structures here. We have optimized the geometry so that all the connections, all the distance between layer n and layer n+1, for example, is always the same for all the connections. And we choose to use circular profile, pipe profile, because those pipes, they don't have any orientation in space. And between 2 curves in space, there's a rule that says that you can always find a line or a segment that is always perpendicular to those two curves. And so because of this kind of optimization, we were able to design a connection detail that can self-adjust its position on the profile, that can self-adjust all the rotation angles between the profiles. And also we add another adjustment layer. And this one was necessary for the installation, during the installation of those profiles. And then after we applied these details everywhere. So even though this surface was very curved, completely like without rules, after optimization of the structure, after optimization of all the structural members, we were able to apply the same details everywhere, which helps a lot during the installation, during the construction, during the fabrication, for the budget as well, of course. And by the way, we applied the same kind of logic a few years later on this MAD project in Xiamen. This same kind of thinking, same kind of logics. The second point I would like to show you that is very important for us when we start to work on projects is about what I call reduction. And more specifically, like reducing the complexity. So this is actually, I'm not sure I am able to show this project, but because this is a very, very recent project that has not been released yet. But anyway, I mean, here is the architect is also in Shanghai. This is project in Shanghai. The architect Yu Ting from Utopia came to us to help them to build. Basically, they had this scheme, this concept, and they came to us and to basically to help them to get it built. So very curvy geometry, very highly double curved, and they have this intention to use like very big, smooth panels, stainless steel panels. They wanted to use like blue stainless steel panels. So you can imagine all this level of complexity when we start to think about fabrication and waterproofing and all these kind of considerations. And this is what was on site when we first came for our first meeting with client and architect. So the main structure was already built by the client team itself. They have a small construction team and they already built it. Basically, they took the model from architect. They said, well, it looks approximately like this. Okay, and they built it like this. All the curvature, all the connections was approximately looking the same than the reference surface. And so we came to this to the site. This was in July this year, okay? And we had a kind of kickoff meeting with client and architect together. And the architect presented us to the client like this. He said, okay, Mr. Client, here is Florian, our bespoke. And he can optimize, simplify any double curve geometry into single curve geometry without changing any design, anything on the design. He literally said that to the client, really. So it was a bit funny to see how people are seeing us and like presenting us to others, you know. And so first of all, when I hear that, because I hear that quite often actually, people come to us and say, okay, you can do your things, but give us a rationalized geometry or like help us to build it within our budget. And the first thing I say to them, to reply to them is that, of course, yeah, okay, we will think about it. We will put some energy on it, but we are not magicians. We are not doing magic, okay? So I asked them a little bit of time to think about some potential solutions, what directions we want to take to get their projects maybe built. And then we left, and I was like almost out of the building, and the client told me, by the way, Flo, this has to be finished end of September. It's really true. It's really true. So this was adding another level of another challenge to the problem. So I took some time, not too much, to think about what kind of solutions we could apply to get their concept built. And here we actually chose or proposed to them a radically different solution. We decided, instead of using large panels with double curve geometry, we decided to discretize the surface with smaller units, which could be potentially identical or with some groups, with some like k-means clustering. You could actually, for this kind of geometry, group the panels by type, because when we see this kind of geometry, this is quite difficult to get all the tiles the same. But at least this is reducing the complexity of the paneling that they were having at the beginning. And you know, when I was, and they quite liked this idea. Okay, this idea, they were happy because it was solving most of their constraints, you know, because of time, because of fabrication, because of budgets. They quite like it. And so with my colleagues, we started to dig into this solution. And when we were on the computers together, I was telling myself that seeing their geometry, maybe on this project, we will have like about 6, 7, maybe 8 types of tiles to fit and to panelize the whole geometry. Finally, we only got one type. So we optimized all the grids so that the whole geometry can be panelized with only one type of units. This is like blue stainless steel, like they wanted, 1 millimeter thick, or 0.9 or 1 millimeter thick blue stainless steel small panels with this kind of shape, which actually like remind the W of Utopia, okay, from this architect. So they also liked it. And there's only one type. It was like when receiving those ones, they still had this plastic cover on them. So still need to remove that before you can install that. And, you know, I mean, even though there is only one type of tiles on the geometry, because it's all very, very curvy structure, very curvy surface, all the grid is still distorted. All the space between the rows, if you want to have the overlapping of the tiles working everywhere, and if you want to have not to see the connections, then each tile needs to be slightly adjusted and slightly rotated in their plane so that you can get this with only one tile. And so at that time, I had two choices, and we were discussing this with my colleague. Or we give to the workers an Excel table, for example, where we have all the coordinates of each tiles and all the space between the rows, you know. And then during one evening, I said, okay, maybe in order to, again, make the life of workers, and I was part of the workers, make their life easier, maybe we could print the whole pattern on a 1-to-1 scale on a very thin fabric, very cheap, glue that on the base surface so that when they install the tiles, they don't have to think. And it's becoming like very they don't have to think too much, and it's like reducing mistakes. It's helping them, and they were quite happy to see the things evolving like very quickly and put that together. We put some color code so that they know which row to install first, because this kind of tile system, you have to install it in order. You cannot install this one first, because otherwise you cannot put the one below after. It's quite interesting, easy at the end, and interesting solution that we provided to them. And this is a view from the roof. This is interesting to see this color variation. So there is only one color, but because of the angle that you are looking at, because of the light reflection, there is a gradient of blue coming from this curvy geometry. And you know, this kind of fish scale option is actually also bringing like another level of texture on the building. When you're far away, you basically don't see it. And the closer you get to the building, you start to see the details. And when you get really when you can touch it, you can touch those scales. This is like another level of experience for users. I don't know how they will use this building, but this is, So yeah, when I was saying that this is not yet released, is that we did not meet the deadline. We finished it like 2 weeks after, so middle of October. So now I think these days architects are taking pictures of this building and this will be released quite soon. And the last point that I wanted to show you is about like what I call avoiding black box. So you remember this project where I showed the details that we designed for this one. So after we worked on the geometry, after we developed some solutions for the detailing, this was not yet ready to go for construction, to go for production. Here, all the profiles, the curved profiles were having like a continuously changing curvature radius over the lens. So I'm not saying that this is impossible to fabricate. There are very few factories in the world that can fabricate these kind of profiles. So you have to find them. But most importantly, it's extremely difficult to fabricate these kind of profiles, like spline profiles, bend these kind of profiles with the tolerance that was required for this project. So we started to think again on this problem, how to make it easier for fabrication. And then we started to develop some process so that every single profile were fitted or transformed as a series of tangent arcs. Could call it that poly arcs, for example. And if you zoom here, actually, this was done like in 2014, if I remember, yeah, 2014. At that time, maybe I did not search enough, but I did not find a tool that was able to provide us what we need. Exactly what we need. There was some tools, but it was not exactly what we needed. So I decided, okay, let's spend some time and try to develop it ourselves. Try to make it ourselves. Try to put. Yeah, you see, I mean, this is a very small definition. It's not complicated, but we did it ourselves, and this way we were able to trigger all the inputs that we wanted, all the parameters that we wanted to put in, and we were able to get the exact results that we were needed. And for this, so we fitted all the curves, all the profiles with those algorithms. And we did set up like a target deviation of like 10 millimeter between the reference curve to the fitted polyarc curves. This was the results after simplification. And then after this, the factory, they decided to try and to give a try. Before this, it was just telling us, no, we cannot do this, or we don't want to take the risk because we are not used to do that. So we discussed with them, checked their production capacity, what they are able to do. And then after explaining them how it was rationalized, then they tried it. They pre-assembled everything in factory to validate the whole geometry. Then we did some mock-up. Those tiles, they are actually LED within the glass lamination. This was like pictures during the installation on site. And this is the final objects, the final projects. And the last point, the last example I want to show you is about this detail. So you remember this canopy in Shenzhen, right? Frankly speaking, I did spend quite a lot of time on this one. Because you have to imagine, this was, if I remember well, was done in 2000, 13 or 14, I guess. So at that time, T-spline, I'm talking about Rhino, I'm a Rhino user. T-spline in Rhino was already out almost. And at that time, all the sub-D that we got in Rhino 7 was not there anymore, was not there yet. But I had this idea of these three columns, you know, and I wanted to build this detail. And I knew that with enough time, enough energy, you can get it right. When I say get it right, is getting all those constraints right. Because as structural engineer, you know, the force flow between those branches, between the main trunk and those branches is very important. So you need to get all this tangency right. Getting all those curvature between the profiles also right. Constrain all those members to be a perfect cycle. This was also a challenge. Even today, with constraining like sub-D edges, it's not easy. Even though there is some hidden comments in Rhino 8, but this is something else. And so we did it, same as the project before. We developed these kind of tools to generate this shape. And the thing is, what is great today is even with sub-D in Rhino, even with all these kind of new tools that came to us every day, are coming to us every day, I'm still using the definition I made in 2013 because it's working well. And if today we have to design a node with 20 branch, we can do it. And you know what is great as a young engineer is that you spend time on the models. You spend time to develop some solutions to real problems. And then a few months later, you get it built in factory. You see it. You go to factory and you discuss with workers. And yeah, this is what you saw a few months before on your screen. This is like very rewardful. So this is a casted steel piece. And the mold for this piece was done in sand. The whole piece weighs approximately a bit more than 5 tons. So 3 points to finish and as a conclusion. For us as an engineer, to keep control over all the processes that we are designing, we have to be the one that are driving the tools and not the opposite. Today, I personally think that we are not using more than 10%, or even a lot less, actually, maybe more than 1% of all the tools capabilities that we have today. And even less if we think about combining those tools together. So we, as Arthur was saying this morning, it's like we have new tools every day. I mean, things are going too very we don't have enough time to master the things, and we have another tools coming. So it's a very strange period. And yeah, I believe the last one is that I really believe that today we are not constrained by tools anymore, but we are more constrained by our creativity and imagination. And this is actually an echo to the first page of the presentation, because an engineer imagines. Thank you.
I think, okay, we can leave it as is. So as I announced before Florian started this presentation, we moved from, let me put it this way, the digital dreams from Arturo to the solid reality. And I'm sure the Italians will understand even more what I mean with solid reality, with 5 tones, steel node, okay, after the Umberto Boccioni 4.0 in the futuristic approach, futurism approach from Arturo. Is there any question from the audience? Oh yes, we have you.
Florian, how does the drainage work in the middle panel at the top center?
The blue one, right?
Yeah, I didn't see a picture. I'm sure there are areas of drain in the middle.
No, we leave it as a pool. It's an accessible pool on the road.
Why fighting water when you can use it for a pool, no?
Yeah. No, of course, yeah, we thought about this. And so first of all, yeah, there's 2 layers of drainage. Okay, we did not rely on this blue scales, fish scales too. In theory, it could be because of the geometry, but in theory.
It's the client.
My English is so bad. Yeah, there's 2 layers of waterproofing, water barrier. Under the blue scale, scales, there is another layer of waterproofing. Real layer. The real waterproofing is underneath, and at every low point at those like double curved surfaces, we have drainage that is actually because there's 2 layers. This is almost hidden on those pictures that you saw. You don't really see it, but there is some drainage in the middle, and then the drainage is going inside, and then following the structure on the to drain the water on the side of the building. Yeah. There is actually 2 drainage for each surface, just in case of like a redundancy, just in case of for safety. Basically, if one is broken or if one is obstructed, then we get another as a security. But yeah, you see these kind of questions at the beginning. The architects, they did not really consider this. Not really. This is first. No, I'm not saying that. Architect versus engineer.
No. You're not saying that. You said it. That the whole audience noticed.
But this is the first thing I saw when I saw this building. When the architect comes, drainage. How do you do it? How do they do it? Yeah.
Okay. Next question.
No, thanks so much for your lecture. It's really very interesting because you make it look simple and you talk about simple things, but they are not at all simple. I want to ask you something, especially in relation to all the architectural versions of technology that we have seen in the morning. A lot of the time in the creative areas of our jobs, we rely on ambiguity to make us think, to make us dream, to make us come up with new solutions. You work on a very different paradigm. You talk about abstraction and simplicities, but what do you do? What is the move that you do to get the new idea? Because that is a jump, you have to get the abstraction and the simplicity from somewhere. So how do you move yourself out of the simplicity to see more and maybe to be a bit more vague?
Yeah, I mean, this is on every project that are coming to us. People are coming with like crazy ideas and crazy wish, buildings that are really looks infeasible on the papers, and then we are taking those challenges. I'm not saying that everything we got built is. We've got it built in an easy way and without efforts. This is a lot of efforts, and this is we are spending energy on trying to get this kind of rules applied on each of our decision-making process. Means that we try not to jump too fast into Grasshopper or into this kind of digital tools, because according to experience, I have seen too much this case where you get lost in all your thinking when you move too fast and you go into the tools too fast. And so this is why we like to go back to the basic at the beginning. You know, when I was trained by all those really great engineers from RFR. They were like experts in geometry, experts. So I've been really at the beginning as a young engineer, like learning like the basic rules, you know, of mathematics. You know, the basic learning, the basic principle of the geometry. All the books from Potman, you know, it was on my desk like and I was working really a lot. When I'd say I spent 8 years in RFR, it's literally 8 years in the office, learning a lot and learning really like crazy. And so also to open your mind, you know, and see things everywhere and open, not just get restrained to digital tools and get, okay, I know I have this plugin, I can make this with this plugin, and don't having the control over the design. I spend quite a lot of energy to, let's say, take some height and see the problems, try to see the problems from the origin, and not just like having a problem to solve. Okay, I have this tool to solve it. Okay, maybe there's 10 tools that can solve this problem. Maybe, and if you have to think about a solution for this same project, you will use another way, another approach. You will use different tools. So I'm not saying that the way we choose, the path we choose for each project is the only right one. There's many of right paths. It's just one of them. And yeah, it's we try to elevate a little bit our decision-making process when we work on projects. So from the beginning, when my colleagues, many of my young colleagues that are sometimes coming from this university, by the way, they tell me, "No, Flo, I'm lost. We are stuck here because Grasshopper cannot do it." And I say, "Okay, then you take your Grasshopper, throw it away, and think again." This is really what I tell to them. Okay, if you are stuck because you are lost in Grasshopper, it's not because of Grasshopper, it's because of them. And of course, I help them and we discuss together. It's like it's not, I don't let them to do this trip themselves. We discuss together. I share my experience. And then we try to come up with new solutions. Okay.
Thank you very much. So I've received precise orders that in order to go on with the program, that the one from Kenny was the last question from for this keynote. I saw signs like 3 p.m. coming. So I cannot say no to Mia and Giancarlo. So I'm outsourcing the responsibility. So thanks again to Florian. I would like to invite everyone to join the next 2 parallel sessions in AI 103 and AI 107. I will just also kindly ask Arturo, Mia, and Giancarlo to come here for a picture with the 2 keynote speakers for today. Thank you very much.